Hi guys, welcome again to Science in 5. In this video, we're going to discuss what happens now when there is a transfer of charge between two materials. So in this example, we've got material Q1 and Q2. We're going to use the blue dots to represent negatively charged particles, the red dots to represent the positively charged particles. Okay, so what is the amount of charge in material Q1? Well, the amount of charge in material Q1, we're going to add the 2 positives and the 6 negatives, gives us a relative charge of -4. And the total amount of charge in material Q2 is going to be the positive 3 charges, and the -3 gives you a total of 0. So we can see that material Q2 is actually neutral. Okay. What then happens when those two materials touch each other? There's going to be a transfer of charge. Since they're similar sized objects, it means the charges are going to be shared between the materials. Okay, so we can actually calculate the total charge of the system. The total charge of the system will be the -4 plus the 0 that we had. And this will give you a total of -4. Okay, now there's going to be a transfer of charge between these two materials. Okay, so the electrons will move from the more negative material to the less negative material. Which is the more negative material? Well, it's Q1. So the electrons will move from Q1 to Q2. Okay, like that. So the electrons will move from Q1 to Q2 until the charge is evenly distributed. So since the charge is now going to be evenly distributed, it means we can actually work out the new charge on each sphere by just dividing the total charge by 2. So the new charge on each sphere is going to be -2. Okay, now in terms of a formula, we can say this is referred to as the principle of conservation of charge. When we're going to get to a formula rather. So the total charge of an isolated system remains constant during a physical process. So, which means in terms of a formula, the new charge on each sphere, so this is the new charge on each sphere, is going to be Q1 plus Q2 over 2. If there were 3 similar sized spheres, we're going to add Q1 plus Q2 plus Q3 and we divide by 3. Okay. All right. 2 similar sized metal spheres X and Y carry charges of 3 mc. What is m? M is milli. Okay. M is milli. So this little m is milli. And what does milli refer to? Well, milli means times 10 to the -3. Okay. They're allowed to touch and then return to their original positions. Calculate the new charge on each sphere. We're going to simply apply the formula. Q new is Q1 plus Q2 all over 2. Q1 is 3 times 10 to the -6 plus 7 times 10 to the -6, all of that divided by 2. Okay, so this will give you, need a calculator now, 3 power minus 3. I don't know why I changed it there. Get me running. It's -3. So beware there. So it's -3. And then there is also a 7 All of that is divided by 2. And I get an answer of 0,005 Coulomb, or using scientific notation, 5 times 10 to the minus 3 Coulomb, 5 millicoulombs. Okay, so that is it. Just simply apply the formula Q1 plus Q2 divided by 2. We'll get our new charge, 0,005 coulombs. Okay. Now in this question, we are told two similar sized metal spheres A and B have charges of 2 nanocoulombs and negative 0,5 nanocoulombs respectively. The charges are allowed to touch and then return to their original positions. We are asked to state the principle of charge conservation. We've just stated that one. The total charge of an isolated system remains constant during a physical process. Okay, so that one we've gone. It says calculate the charge on each sphere after the return to the original positions. So we are using the Q nu formula for number 2. Q nu is Q1 plus Q2 all over 2. We already know that nano means times 10 to the minus 9. And then we just be careful of negative 0,5 times 10 to the negative 9 all over 2. Again, we use our calculator. 2 to the power times 10 to the power minus 9 plus negative 0,5 times 10 to the power of negative 9 all over 2. This gives us 7,5 times 10 to the minus 10 coulombs. And then the principle of charge quantization, in the previous video we spoke about it. Do you remember what it says? Yes. All charges are made up of the integral multiples of elementary charge. Okay. That's the principle of charge quantization. Do electrons move from A to B or from B to A? So which is the more negative of the two charges? B. This is the more negative. There's more electrons here. So electrons are going to move from where there is more of them to where there is less. So it's from B to A. And number 5 says calculate the number of electrons that are transferred. Okay, calculate the number of electrons that are transferred. So we already know, number 2, that the charge is 7,5 times 10 to the minus 10. We're going to need that value. Okay, so to calculate the electrons that are transferred, let's start by calculating the charge transferred first. So we need the charge that is transferred. Okay. It's going to be the final charge minus the initial charge. Now here we can either use either one of them. We should get the same amount of charge. Okay. So for example, if I use A, what is the final charge of A? It's 7,5 times 10 to the minus 10. The initial charge of A was 2. The negative 9. Okay, so I'm going to grab my calculator again and I'm going to subtract those two numbers. And I get negative 1 times 10 to the minus 9 coulomb. Okay. I'm just checking. 7,5 times 10 to the minus 10 minus 2, the power of negative 9. It gives me actually, if I round off quickly, it gives me that answer. The correct answer is 1,25. Because I was looking at that number, why it's not looking like it's correct. It's negative 1,25 times 10 to the minus 9 coulombs. All right. What if I use B? Will I get the same answer? Okay, let's check. If I use B, using the same formula, final charge minus initial charge, the final charge is the same. It's 7,5 times 10 to the minus 10 minus the charge on B is a negative 0,5 times 10 to the minus 9. Okay, so now I got 7,5 to the power of minus 10 minus negative 0,5 to the power of minus 9. I get a positive 1,25 times 10 to the minus 9. Notice the numbers are the same. The signs are different. This one is a negative 1,25, but this one is a positive. In other words, it's the same amount of charge that is transferred between the two. Okay, so it's the same amount of charge that is transferred. So it doesn't matter whether you use A or B, you should get the same amount of charge because you are using this formula here. The charge transferred is the charge final minus the charge initial. Now, once I know the charge that is transferred, now I can calculate the number of electrons transferred. In this case, the number of electrons that are transferred is going to be the charge transferred over the electronic charge. So the charge transferred is the 1,25 times 10 to the minus 9, electronic charge 1,6 times 10 to the minus 19. Okay, again, using our calculator, we end up with 7,8125 times 10 to the power of 9 electrons. Okay, so that's it, guys. That's it about charge transferred. So to calculate the charge transferred, the number of electrons transferred, you're going to need to know the final charge, and you need to know the initial charge, so that will give you the charge that is transferred between the two materials. It's transferred. Once you know the charge transferred, now you can get the electrons transferred by dividing the charge transferred over the electronic charge. Okay, so, and remember, during transfer of charge, okay, the charge is going to be shared equally between the two spheres. If there are three of them, it will be shared equally between the three, and you're going to need to use this formula that says Q nu is equal to Q1 plus Q2 over 2. So in a nutshell, when it comes to calculations involving the transfer of charge, these are the formulas that you need to be aware of and know how to use them. There are basically three of them. Okay, you need to know how to use these three formulas, and then you're home and dry as far as the transfer of electrons is concerned, as far as the number of the charge transferred is concerned, as far as the final charge on each sphere after they've been allowed to touch and return to the original positions. So that's it, guys, about the second part of electrostatics. We now know what happens when charges are transferred. In the next video now, we need to talk about the force that exists between stationary charged particles. There's an interesting law that is there, then interesting calculations that are there. Hope you'll enjoy that video as well. I'll see you guys around next time. Please share this video, subscribe,